Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 2 and Lesson 10 and 11, which deal with more factoring of quadratic expressions. In our last video, we looked at how we could factor quadratic expressions um, that start with a coefficient of 1. So that first term in our ax squared plus bx plus c, the a was always 1. We started with just an x squared. What happens if we have something other than 1? So in this lesson, we want to look at how do we deal with factoring when we have something other than 1 as that leading coefficient. And so we do have some steps here that we're going to follow, and I'm going to go through an example here with this first quadratic expression that we have, 4x squared plus 24x plus 32. And remember, we were identifying what is our a value, what's our value for b, and what's our value for c. So those are those coefficients or constant here in the last case. So in this case, a is 4, b is 24, c is 32. Well, the first thing we want to do is we want to see, is there a GCF, a greatest common factor, that we can factor out of that expression? And if you notice here, each of these terms is divisible by 4. And so I can factor out a 4 from that expression, dividing each of those terms by 4. So 24x divided by 4 is 6x, 32 divided by 4 is 8. And so now I have a little bit simpler expression to work with. And notice this one, it actually now gave me a value with the x squared term of 1. So at this point, I could use the steps that we went through in our last video to factor this one. But I'm going to go ahead and use the information we have here, follow these steps, and we'll get to the same place. So it says we want to find two numbers that multiply to give us AC and add to give us B. Well, now our A is 1 and our C is 8. So A times C, 1 times 8 is 8. So we want to think about what are two numbers that multiply to give us 8. And so thinking about our factors of positive 8, it could be 1 and 8, could be negative 1 and negative 8, 2 times 4, or negative 2 times negative 4. And so in this case, we also want them to add up to give us what our B term is, which in this case is 6. And so 2 and 4 are going to be the two numbers that multiply to give us 8 and add up to 6. And so what we're going to do with those two numbers is we're going to rewrite that bx term, that term in the middle, using those two. And so you may hear this referred to as split the middle, is another way that this is sometimes referred to, this method. But so I'm going to rewrite that 6x in the middle as a positive 2x plus 4x. All right, so we found our GCF. We found the two numbers. We've rewritten that middle term, so we have our quadratic expression here. So our next step then is we want to factor out a GCF from the first two and the last two terms. So we're looking for what's the GCF of those two. So x squared and 2x. Well, I could factor out an x from each of those terms. So x times x would give me x squared. X times a positive 2 would give me 2x. So we took those first two terms and factored out the GCF. Then we're going to do the same thing with the last two terms. So 4x and positive 8, well, they have a greatest common factor of 4, or a positive 4. And so 4 times x is 4x, 4 times positive 2 is 8. And so that was my step 4 to factor out a GCF from each of those pairs. And then our last step here, once we have factored that, the quantity that it's talking about here should be the same. So we have an x plus 2 in those parentheses. And so What that allows us to do is we can then rewrite this. Whatever has been factored out, the x and the positive 4, that's going to be one of our sets of terms. And then the x plus 2 is going to be our other. And so this is going to be our factored form, 4 times x plus 4 times x plus 2. And you'll notice that the 2 and the 4, that's what we had here. And so since we had an a of 1 with this, our started with a leading coefficient of 1, once we found those numbers, they would become our terms in the middle. But wanted to go through that these steps because there will be times where we don't end up with that a value of 1. So let's look at an example of that down here below. So I have 5x squared minus 13x minus 6. And so our a value here is 5. Our b is negative 13, and our c is negative 6. First step, we want to always see, can I factor out a GCF? Well, 5, 13, and 6 don't have a common factor among those, so we don't have a GCF to factor out of this one. So in step 2, we want to find two numbers that multiply together and give us a times c. So we need to multiply our a term and our c term together. So 5 times negative 6 is negative 30. So we're looking for two numbers that when we multiply them together, give us negative 30. And when we add them together, give us our b value, which is negative 13. So at this point, we want to find all of our factors of negative 30. So I could take 1 times negative 30, negative 1 times positive 30, 2 times negative 15, negative 2 times positive 15. We have 3 times negative 10, negative 10 times, or excuse me, negative 3 times positive 10. And then we have 5 times negative 6 and negative 5 times positive 6. So a lot of different possibilities here. We want to find the pair that will add up to that negative 13, our b term. And if we look through those, if we add 2 and negative 15 together, we're going to get negative 13. So those are the two that we want to use here. And so our next step here, number 3, we want to rewrite that middle term. So we're going to replace the negative 13x in the middle with a positive 2 and a negative 15. And I'm going to put the negative 15x first because if you remember, we're going to end up factoring the first two and the last two. And so that will, I know that 15 and 5 have a common factor. So I'm rewriting negative 15x plus 2x is replacing that negative 13x in the middle, and then minus 6. All right, and so now we're going to factor the first pair here, 5x squared minus 15x. Well, I can factor a 5 and an x out of each of those terms. So 5x would multiply by x to give me 5x squared, and by negative 3 to give me that negative 15x. Then my second set here, 2x and negative 6, I could factor out a 2, a positive 2, and that would leave me with x minus 3 again in the inside the parentheses. So now if these match, then I can rewrite that as 5x plus 2 times x minus 3. That is going to be my factored form. And remember, you can always check these. If I would go ahead and multiply these back together, I should end up back where I started at 5x squared minus 13x minus 6. All right, and I've got one more example for you here 2x squared plus 13x minus 24. A in this case is 2, B is 13, C is negative 24. And so we multiply A times C, 2 times negative 24 is negative 48. I kind of skipped a step there. I do want to see if there's a greatest common factor, but again, there's no greatest common factor to factor out. So on step 2, A times C is negative 24. I need factors of that negative 24, or excuse me, negative 48. So 1 times negative 48, negative 1 times 48, 2 times negative 24, negative 2 times positive 24. We would have 3 times negative 16, negative 3 times positive 16, 4 times negative 12, negative 4 times positive 12, and then finally 6 times negative 8 and negative 6 times positive 8. So those are all my possible factors. I'm looking for the pair that will add up to positive 13. And if you look right here, negative 3 plus 16 would give me a positive 13. So I'm going to use those two to rewrite that middle term. So 2x squared plus 16x minus 3x minus 24. So positive 13x, we split that into positive 16x minus 3x. Now we're going to factor 2x squared and 16x have a greatest common factor of 2x. And that would leave 2x times x plus 8, because 2x times x is 2x squared. 2x times positive 8 is 16x. And then my negative 3x and minus 24 would have a greatest common factor of negative 3. So negative 3 times x is negative 3x. Negative 3 times positive 8 is negative 24. So again, we have the same x plus 8 inside my parentheses. So I can now rewrite this as 2x minus 3. 2x minus 3 becomes the first. And then x plus 8 is my second set of binomials. All right, and so that's how we go about factoring a quadratic expression with a leading coefficient of something other than 1. As always, if you do have questions, please let me know. Thanks, have a great day.